this question. So we will be doing some say rules. So the first rule is the power rule. So it says that we know that d of xn, firstly with respect to dx, is equal to n x to the power n minus 1. What is n? N is, n belongs to any integer. So example, if I have to give an example, we know that d of x square by dx is equal to, this is n is 2 in this case, so 2 into x ki power 2 minus 1, that is 2x. Okay, and this is the first example. The second example is say d of x to the power 6 upon dx. It will be equal to, n is equal to 6 in this case, so 6 into x to the power 6 minus 1, that is 6 into x ki power 5. Okay, so we have learned the first rule, that is power rule. Second is, what is d of, let's say, lambda into f of x upon dx. Now lambda is a constant and fx is a function of x. So d of lambda into fx upon dx is nothing but lambda into d of fx upon dx. So we can take this lambda out of this d function. So that is lambda into d of fx upon dx. So for the sake of example, d of 2x upon dx is 2 into d of x upon dx, and that is basically 1. So we get 2 as the answer. In this case, in this example, fx is equal to 2, fx is equal to x, and lambda is equal to 2. So that is the example number 1. Let's say the second example is d of 3x cube upon dx. So in this case, the lambda, so lambda is 3 and x cube is fx. So it can be written as lambda into d of fx upon dx, which is equal to 3 into d of x cube upon d of x. Now in order to find this d of x cube, we have to apply the power rule that says that 3, it is as it is, this 3 now into this 3, that is n in this case, 3 into x to the power 3 minus 1. So it comes out to be 9x square. Okay, so we have looked at 2 rules. Now the third rule is, let's say we have d by dx of fx plus g of x. So this will be equal to d of fx upon dx plus d of gx upon dx. Okay, so in this, both f and g are function of x. So its example, let's say the example 1 would be d of x plus x square upon dx. It will be equal to d of x upon dx, that is the first function. So this is the first function, plus d of x square upon dx. So the second, this is the, this x square and this x square comes here. Now just this is equal to 1 and this is equal to, we have to apply power rule. So this 2 is the n here, So 2 into x to the power 2 minus 1, that is 1 plus 2 of x. Now let us take another example, example 2, which says that we have to find d of 3 plus, let's say, 2x square minus 3x and upon d of x. So instead of two function f and g, we have now three functions, namely 3 and 2x square, and another function is 3x. Okay, so now just break it in case of d of f plus g, we broke it into two parts, df plus dg. Now just break it in three parts, so it will be basically d of 3 by dx plus d of 2x square by dx minus d of 3x by dx. Now why we have written this minus? Because here it is minus, so we can say that d, we have to see this, d of fx minus gx upon dx is equal to d of fx by dx minus d of gx upon dx. So if there is plus, then it will be plus. If this is negative, it will also be negative. So coming back to the question which we were discussing, in this case this 3 is constant, so a constant cannot change, hence it is equal to 0 plus this 2x square is 2 into 2 into x to the power 2 minus 1, and this is minus 3 constant into dx by dx, that is 1. So we are left with 4x minus 3. Now in this question we have used this thing, that d of constant upon dx is equal to 0. Why? So let us draw x-axis and y-axis, and let's say that this is this constant c. Now according to the definition of this function d of constant by dx, so if we draw a tangent line, we know that in case of straight line this will be the tangent line, and we have to look at the slope of this. So as this line, this c is constant, so it is parallel to x-axis, which implies its slope is 0. That's why we are using this thing. Okay.